All right, PreCalc, here we are with 2.3, synthetic division. I know how much you guys liked that in Algebra 2. Okay. In this section, we're going to look at two procedures for dividing polynomials. All right. And these are helpful in finding zeros. First one we're going to look at is long division, okay? In order to appreciate the shortcut, you got to do the long cut, okay? So divide 6x to the third minus 19x squared plus 16x minus 4. Divide that by x minus 2. And then use your result to help factor the polynomial completely. Okay, so we got x minus 2 on the outside. 6x to the third minus 19x squared plus 16x minus 4. All right, let's see if we can remember how to do this. Okay, so we take our front divided by the front. 6x third divided by x is going to be 6x squared. And now I take that 6x squared and I multiply it back to both pieces. So 6x squared times x should match this one, 6x to the third, minus 12x squared. Okay, now this is the trickiest part. Okay, I think this is the trickiest part because you subtract down. So sometimes I'll put a minus in parentheses. I'm subtracting both of these down. So 6x to the third minus 6x to the third, that should cancel out, right? The first one should always cancel out if you did this first part right. Negative 19 minus negative 12. So it actually is like a plus 12. See, that's the tricky part. When we get you get a lot of minus negatives that you have to watch out for. So this is actually going to be negative 7x squared. Negative 19 minus negative, so actually plus 12. And then we bring down the next one. Plus 16x. Negative 7x squared divided by x is going to be negative 7x, right? Front divided by front. Negative 7x squared divided by x is going to be negative 7x. And again, multiply it back. Negative 7x times x, negative 7x squared. Negative 7x times negative 2 is a positive 14x. And again, subtract down. If you can remember to subtract down, that's great. Otherwise, I think this does leave, if you don't do this, but you can still remember how to do it, that's great. But it does open yourself up to errors, really easy errors here. So negative 7 minus negative 7, that cancels. 16 minus 14, 2x. And then we bring down the minus 4. 2x divided by x is just positive 2. And these do work out perfect. So no remainder. Fantastic. I had an idea that it was going to be no remainder when it said use the result to factor completely. That usually means that this is going to come out pretty clean. So x minus 2 is a factor because it went in perfectly. And we also have 6x squared minus 7x plus 2. Okay, so now we got to factor this. And you can do guess and check or whatever factoring techniques you've learned up to this point. I like to go with front times back, what multiplies to 12 and adds to negative 7. How about a negative 3 and a negative 4? And now because I did front times back, now I have to come back and divide by that front and reduce. Negative 2/3, negative 1/2. If they don't come out perfect, the bottom number slides up in front. X minus 2 times 2x minus 1, 3x minus 2. And there it is. Okay, so that was a lot of work. All right, that was a lot of work. Okay, hopefully we get to do a lot of synthetic division that goes a little faster. Okay, in example 1, it worked out perfect. Oftentimes, though, it will not work out perfect. Okay, what do you do then? Okay, so let's look at this. Divide x squared plus 3x plus 5 Divide that by x plus 1. X squared divided by x is x. Multiply it back. X squared plus 1x. Remember to subtract down. Those cancel. 3x minus 1x is 2x plus 5. 2x divided by x is going to be 2. Multiply this back. 2x. 2 times 1 is plus 2. Subtract down. Cancel. 5 minus 2 is a remainder of 3. Remainder of 3. Okay. So maybe before it's a positive 3, so I would go plus 3 over whatever you're dividing by, x plus 1. In fractional form, we could write it like that. We have x plus 2 plus 3 over x plus 1. And what does that imply? That means that x squared plus 3x plus 5 is equal to, we had x plus 1 times x plus 2. And then you would be 3 short, so plus 3. That's what that means. Okay? Bum 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 bum. More fun. Let's see. Oh, more long division. More long division. All right. Well, it doesn't say to use long, does it? I did long division on my first copy here because it didn't necessarily go through synthetic yet, which it does on the next page. So I think they expect us to do long division on this one. This gets sloppy with long division, these big ones. This gets tough, so you got to really pay attention. It took me 2 tries. I couldn't find where my mistake was, or I thought it was a mistake. I came out with a remainder on this one. And the answer in the book did not. So maybe you can catch my mistake. Maybe I won't even make my mistake here. I won't look at my original copy here that I have off to the side. We'll just see what happens. X to the 4th minus 1. Okay, so this is the tricky part. Insert placeholders with 0 coefficients for all missing powers. Right? Don't forget those. So I have plus 0x to the 3rd, plus 0x squared, plus 0x. I always see that as ox, and I laugh a little bit to myself. Plus 1. Got an ox in the middle of my problem. All right. X to the 4th divided by x is going to be x to the 3rd. Multiply it back. X to the 4th plus 1x to the 3rd. Subtract down. 0 minus 1 is a negative 1, x to the 3rd. Bring down the next one, plus 0x squared. Negative 1x to the 3rd divided by x is negative 1x squared. Multiply it back. Minus 1x squared. Subtract down. Okay, negative 1 minus negative 1 cancels out. 0 minus negative 1, that's going to make it a positive 1x squared. I said I wasn't going to look over there, but I did, and so far it's up to the same. So, the book, like I said, the book got a clean answer. I have a remainder in my original copy here. You let me know if you spot the mistake and tell me in class. All right, front divided by front, we got 1x squared divided by x. That's going to be 1x, so plus 1x. Multiply it back. 1x squared plus 1x. Subtract down. 0 minus 1, negative 1x. Plus 1. Negative 1, x divided by x is negative 1. Negative x minus 1. See, and there's where the difference is. Negative 1 minus a negative 1 cancels out. Positive 1. Oh, there's where the difference is. Look at the original problem. Caught it, finally, third try. The original problem is a minus, Mr. Handke. So this is a negative. There it is. I had a plus. Got it. So -1 minus -1, -1 minus -1, no remainder. Whew. Third try. Just need the added pressure of being recorded to finally see the mistake. Yep, that was it. So you got to be careful when you're copying it down. -1, -1. You guys probably saw that right away. All right, I think this is our last long division one. And then we'll get into the good stuff. Synthetic, you like that. It'll be fun. So we're dividing this by that. So we got x squared plus x minus 1 on the outside. Underneath, we got 6x to the 4th minus x to the 3rd minus x squared plus 9x minus 3. This was squared. All right, 6x to the 4th divided by x squared. So 6x to the 4th divided by x squared is going to be 6x squared. Multiply it back to all three parts now. Oh my goodness. Plus 6x to the 3rd minus 6x squared. Subtract down. Front one should cancel. If that doesn't cancel, you did something wrong. -1 minus 6 more makes that a -7x to the 3rd. -1 minus negative, so plus 6x squared. -1 plus 6 plus 5x squared. Bring down that 9x. Minus 7x to the 3rd, or -7x to the 3rd, divided by x squared, we'll have -7x. Multiply it back. 5x squared minus -7, so plus 7 is going to be 12x squared. 9x minus, oh, Mr. Handke, what happened there? Just a plus 7x. I couldn't read that. 9x minus 7x is going to be plus 2x. Bring down your minus 3. Last one, 12x squared divided by x squared is going to be a plus 12. Multiply it back to all three parts. 12x squared, 12x minus 12. Subtract. Cancel. 2 minus 12 is going to be -10x. -3 minus negative, so plus 12, plus 9. So we finish with over x squared plus x minus 1. Oh, yucky. Yucky, yucky, yucky. Okay. I promise we're not going to do long division the whole time, and here it is, synthetic division. Okay, if you don't remember how to do synthetic division, you can read through their little directions, their symbols and patterns up there. All right. And this works for when you have divisors of the form x minus k. All right, so just think of like opposite of this. Opposite of x plus 3, so what's going to make that equal 0? -3. Goes in the box. Okay, and then you take coefficients, and don't forget 0 placeholders. So I have 1 x to the 4th, 0 x to the 3rd, -10x squared, minus 2x, and a positive 4. Skip a line on your paper, draw a line. First number always goes straight down, 1. Underneath the line, times the number in the box, put it in the next spot. 1 times -3, -3. And we always add down. See, it's crazy because long division, you're subtracting down. Synthetic division, you're adding down. So 0 plus -3 is -3. -3 times -3, positive 9, add down, -1. -1 times -3, positive 3, add down, positive 1. 1 times negative 3 is negative 3, add down 1. The last spot is your remainder. So, when I divide x to the 4th minus 10x squared minus 2x plus 4 by x plus 3, I get, so because you're dividing just by x to the 1st and then a constant, this is going to bump it down 1 power. So this is always going to be 1 power less than what you started with. So this is x to the 3rd minus 3x squared minus 1x plus 1 with a remainder of positive 1 over x plus 3. So much more fun than the long division. But this one doesn't work for things bigger than like x plus or minus something, right? If you're going to divide by like 2x squared plus 3x plus 4, then you got to do long. Okay, so you get a remainder, which brings us to the remainder theorem, which says if you do synthetic division by a number and you get a remainder, that remainder is the same as doing f of that number. So if I were to put negative 3 into my original function, the answer would be 1. It's math magical. Okay, let's have you try it. I'll get you started, and then you can push pause and try it out. So 3x to the 3rd, 8x squared, 5x minus 7. Skip a line, draw a line. All right, you push pause and see if you can figure out what f of negative 2 would be using the remainder theorem. All right, welcome back. Let's see how you did. Bring that 3 down. Negative 6. Add down positive 2. Negative 4. Add down positive 1. Negative 2. Add down negative 9. You doubt me. How dare you? 3 times, parentheses, negative 2 to the 3rd. Plus 8 times, parentheses, oh, too far. We got to bring that down. Bump back down to the ground. Plus 8 times, negative 2 squared. Plus 5 times negative 2 minus 7. 3 times negative 2 to the 3rd. 8 times negative 2 squared. 5 times negative 2 minus 7 more. Drum roll. Negative 9. Told you. Math-mazing. Okay, I believe the last page here. I believe it's the last page here. I hope. Yep, last page. So, using that theorem, that whatever the remainder is the function value, we can really look for zeros. Because if there is no remainder, and goes in perfectly, that means it's a 0. And that's what we spend a lot of time trying to find in algebra. And then because of that, it's applicable in PreCalc. So, show that x minus 2 and x plus 3 are both factors of this, and then find the remaining factors. Okay, so here's what we're going to do. So we got 2x to the 4th, 7x to the 3rd, negative 4x squared, minus 27x, minus 18. We're just going to go in order. So x minus 2, remember it's opposite. So it's going to be a positive 2 in the box. Skip a line, draw a line. That wasn't a very good line. 2 goes down. 4, 11, 22, 18, 36, 9, 18, 0. Okay, so they told me that these were going to be factors. Show that these are factors, so these should work out. Now, don't start all over from scratch. You've already divided that out, and now we're down to this. So now, let's see if I can find a different colored pen. Nope. Well, here's purple way over here. So now we're going to do that one. Negative 3. Okay, continue on from here. 2 goes down. Negative 6. 5, negative 15, 3, negative 9, 0. Okay, and that is 2x squared plus 5x plus 3, which is a little bit easier to factor just by looking at it than the x to the fourth one. So this would factor out to, I mean, this is just guess and check. It's such small numbers in the front and the back. It has to be a 2x and an x, okay, and then it has to be a 3 and a 1. Now you just got to figure out what the order is. If I put the 3 over here, that's going to be 2 times 3 for 6x. It's going to be too big. So the plus 3 needs to go here, and the plus 1 needs to go there. 2x squared plus 2x plus 3 more x, that's 5x in the middle, plus 3. Don't forget your original factors. Oh, it just wants the remaining. Find the remaining. So yes, those are the remaining factors. 2x plus 3 and x plus 1. So, the remainder, r, gives the function value of f at x. If it equals 0, that is a factor, which is an x-intercept of the graph. So which can help you with your sketching, which is what this whole thing was about, was sketching. So we're mainly concerned with, can you find the zeros there? That's what the main concern is for today. So there you have it, folks. Almost 22 minutes. Sorry for the length there. There's a lot of problems to do. Best of luck on the homework. Let me know if you have any questions.